Mathematicians are always looking for shorthand ways of writing large quantities or large sums. For instance, if we wanted to write 1 plus 2 plus 3 plus 4 plus all the way up to 20, so we could write it like that. Or we can use special notation, and we use the Greek letter capital sigma, which is like an M or a W turned on its side. That's the Greek letter capital sigma. You know, lowercase sigma looks like that, uppercase looks like that, so sigma. We use that one in statistics for standard deviation, and this one is the special meaning of sum. It's like a letter S, so you're adding up, summing up. Okay, now down below, so we put a variable here, so I'm going to add up n. Now my starting value goes down there, so from n equals 1, and my final value goes up there. You don't put n equals because we know it's going to be n equals. So we've got n equals 1 as our starting value, and our last value is equal to 20. So that means add up. So if you were given that, you would write 1 plus 2 plus 3 plus 4 and write all the numbers up to 20, and you can add them up. So that's how summation notation works. Sigma sign, starting value, and an end value. All right. How could we write 1 squared plus 3 squared plus 4, sorry, we're doing the odds, 3 squared plus 7 squared plus 17 squared. Okay, we want a short way of writing that, so we use our sigma sign. Now the way to write odd numbers generally is 2n plus 1. And the way to write even numbers is just 2n. So this will always generate an odd number. So no matter what value, what integer value you give to n, you're going to get an odd number. No matter what integer value I give to n here, I'm going to always get an even number. So here we were asking for the sum of these odd square numbers. So we'll go 2n plus 1 squared. Now, what is my starting value of n? We can use any letter here. I could use i's or k's or j's or any letter, so we're using n's. What's going to generate my first term here? So I want to get the number 1 inside. So n equals 0 would be my starting value. 2 times 0 is 0 plus 1, so that's 1 squared. My n value, what value of n is going to generate 17? 2 watts plus 1 is equal to 17. 2 times a number plus 1 is 17. Well, that'll be 2 8s are 16 plus 1, so n equals 8 will be my final value. So if you were asked, say, to calculate the sum from I equals 1 to 3, I minus 2 over I squared plus 3. So if you're asked to calculate that, we're going to start at I equals 1, finish with 3, so we've got 1, 2, 3, we've got 3 terms. So it'll be, the first one we substitute in here will be I equals 1, so it'll be 1 minus 2 over 1 squared plus 3. It's always plus. Now we've done I equals 1, now we're going to do I equals 2, so 2 minus 2 over 2 squared plus 3, plus, now we do I equals 3, 3 minus 2 over 3 squared plus 3. First term, 1 minus 2 is negative 1 over 1 squared is 1 plus 3 is 4 plus 0, 0 over any denominator is 0 plus 3 minus 2 is 1 over 3 squared is 9 plus 3 is 12. We need to know our fractions here, so we make them both the same denominator, so we've got to make this into 12ths, so multiply top and bottom by 3, so minus 3 on 12 plus 1 on 12, which is equal to negative 3 plus 1 is negative 2, and 2 will cancel top and bottom, so negative 1 on 6. So we need to be familiar with summation notation. It's a shorthand way of writing a large sum. It's when you're adding up. So not only to be able to get a pattern and come up with the summation notation, but given the summation notation, how to work out the actual answer.